everybody. Thanks for coming. So I will talk about unprivileged container build, basically how to build container image without root and without extra privilege. First, my name is Alban. I'm CTO at Kinvolk. I live in Berlin. At Kinvolk, we are a team of software developers, basically on Kubernetes, on low-level Linux development, on all the stacks in between. If you want to contact us, check this. I will start my talk about how builds were done before containers. And there is always this advice that software should not be run as root. So in the old ways, when you do configure, make install, at least for the build part, everybody advised not to do it as root. And later, when package came, it's the same thing. There is this advice not to run RPM build or dpkg package as root. The reason for that is that we don't. There is a risk for accidental loss. If you make a mistake in your make file, you could destroy your development laptop. And although if you run, if you try to compile untrusted sources, then you don't know what kind of malicious software it can contain, and it's always better not to run things as root. Although when you have build servers, if you want to maintain build server for potential third parties and you don't know what kind of software are being built here, you cannot allow yourself to run everything as root without a minimum of security. So now with the container world, of course, there are many different ways to build container image, but most people use Docker files. That's a hugely popular way. And it's popular because it's easy and it's convenient to use. You can basically build your container from within the container environment. You can use run commands, and it will run inside your container environment, and it's a very convenient way to build software. That can come at a cost, because it's make it quite difficult to run to build container images without root or without some kind of privilege. When you use Docker build, it always needs roots. It could be explicit if you don't run sudo, but it's also, even without sudo, it's implicitly run as root because it talks to the Docker socket and the Docker daemon run as root. So I'm trying to go in a direction where we will not need to have things running as root to build container image. And this is kind of something I would like to have. I would like to be able to build software in Kubernetes without having to tweak Kubernetes to add privilege. So basically, inside a Kubernetes container, inside a pod, you could just run command there without daemon, without being root, and without extra privileges. So we are not quite there yet. Meanwhile, what people were doing, there is a couple of different ideas that are popular too, which one of the ways to use Docker inside Docker. That's not unprivileged because you need to have privilege to run Docker in the first place. Another way is to share the Docker socket from the host inside the container and then use it to talk to the Docker daemon on the host. Yeah, that's although not something which I consider unprivileged because you can basically do everything then on the host. So why does Docker build need root in the first place? That's kind of a regression from before when we build RPM package or Debian package, where a lot of things didn't need to be run as root. In the end, we just want to build a container image that's a bit like a tarball, and there should not be any privilege needed to build a tarball file. There are kind of two reasons why we need to be root to run Docker build. The first one, here inside the script, the Docker file, we can run some commands, and some of them might need to be root to command pattern is to start from the Ubuntu image, and then install package from there. And from that, you need to write file as root, and that's need root. The second reason is to start the build container itself. That's a container by itself, and to start a container, you need to do a lot of operations that are all privileged. So the first one is to set up overlay file system. That's make it easier to keep track of the change on the file system, on, for example, on your new Docker layer that you are building. And to set up the container, you start new Linux namespaces, and that's something which is privileged. Mostly need capsysadmin as a privilege. And then you need to either pivot or chroot or some kind of commands to only view one part of the file system. That's a privileged operation as well. And then most of the commands or scripts you run to build a container, they could be shell scripts or something else. Most of the time, they have some dependencies or they require some basic file system like /proc. So we need to mount /proc as well. On some other basic device nodes like /dev /null /dev /0, a lot of scripts depend on that to run correctly. So that's a lot of things which require privilege, and that make it not trivial to build container image without privilege. So far, we have this table that I listed some operation and some capability required to build container images. And in the talk, I will go through some of them and try to see how we can progress and make it less privileged. There are a few projects recently that try to build container image in a different way. There is not only Docker build, but others one as well. One of them is Builder from Red Hat or Project Atomic. It's a tool to build OCI image. This one is not, at the moment, doing it in an unprivileged way, but there is an open issue about that. And, there is contribution and thoughts about how to do it a privileged way. There is Kaniko from Google, which was announced a couple of months ago. Initially, in the blog post, it was announced at the Google blog post. They were saying it runs without privilege, but actually what they meant is you don't need to have a root access on the host, but still it runs with privileges. So that's they fix that communication mistake. Now in the README, it's clarified that it actually doesn't isolate or allows you to run untrusted build on your cluster. There is Image or IMG, I don't know how to pronounce, which is a really cool project, and that's by Jesse Frassel, and it allows you to run daemonless without Docker daemon and privileged Docker files. And there are quite a few issues which come from the Linux kernel that need to be overpassed to be able to do this kind of things, and I will go through some of them after. There is also Orca build, which is a wrapper on other projects, which does similar things. So how can we make this happen in general? We tools like IMG use user namespace in order to be allowed to run privileged things inside an unprivileged container, basically. Just a quick poll. How many of you know what user namespace are? Maybe 75%, I'm not quite sure. So probably you already know, some of you, what I'm going to talk about. On Linux, user namespace allows to isolate users from each other. And when you run a new user namespace, you are in an environment where you have the illusion of having the full capabilities, but you are actually in a different environment than on the host. And he's doing that basically with user mapping. So on the host, you have a UID, user ID, from 0 for root or quite a lot of different users you can have. When you create a user namespace, you can configure it to give only access to only some range of that. In this example, some user from 100,000 to 200,000 will be mapped into that user namespace, but the other one will not be available. In this example, if we have the illusion of being root, UID 0 inside that user namespace, it's actually mapped to a different UID on the host, so that's not the real root. So you have the illusion of being root, of having all the capabilities, but capabilities are only relative to a specific user namespace. So you might have capabilities with regard to the user namespace here, but not to the initial user namespace. You can do complicated things with nested user namespace, where you restrict further which user ID you give access to. And another thing you can do, as opposed to other different kind of namespaces on Linux, with user namespace you can have unprivileged user namespace. So any user with a privilege can create an unprivileged user namespace with some restrictions. And then you have the illusion of being root there. What it does, to be able to do that, you need to map only one user, because user namespace doesn't create new user, but just map existing one. So if you are user ID 1000, you become root, but only with regard to that user namespace. And from there, once you have your unprivileged user namespace, you can create other namespace, like mon namespace, PID namespace, etc. Because since you have capsys admin, basically capability to do that, with regard to that user namespace, you can create the other namespace you need. And this is possible because all namespaces have an ownership relationship. So in this example, I create a new mon namespace that belongs to that unprivileged user namespace. And that's going to help us because in the table of things to do, I mentioned before, we need to create Linux namespaces. We first create the user namespaces without privilege, and then we get capsys admin inside that user namespace and create other namespaces there. So as I no capability required, but there are a couple of restrictions. Of course, you need to have that feature enabled in the kernel. Some Linux distributions restrict that. For example, Arch Linux, it's hidden behind syscontrol option, but in upstream kernel, it's not restricted. You are restricted in a UID mapping you can do. And in some Docker distributions, you might have a seccomp profile that restricts that. But it's by default, you can do that. So in this table, we progress. We did some of the steps necessary to accomplish the mission. And with that, that's the kind of setup I would like to have, where you have a regular Kubernetes container, where you have your regular namespaces configured by the Kubernetes or by Docker. And within, you can run a program that will set up the build environment, and that build environment will have will be running in a new user namespace, a new privilege, and from that build other namespace that you need to run your commands inside the build container. There are other options, other commands you need to do in the build containers to set up the build container, like pivotroot or chroot or bindmans. And you can do that because you have the privilege inside the build container now, inside the unprivileged build container, because it's always relative to, capabilities are always relative to a user namespace. In this example, I have a process here that wants to run the system called pivotroot, and it has the capability capsys admin, so it should be able to do that, but depending on the configuration, there could be still restrictions. Because pivotroot is a change on the mon namespace, you change the mons. You can only do that if your mon namespace belongs to the user namespace you are in. If you, on the right side, if you try to change a mon namespace that doesn't belong to you but belongs to the host, creating an unprivileged user namespace is not going to help you to do that, because that will break the security boundaries. But by setting up mon namespace in the correct way, when they belong to a new unprivileged user namespace, you are allowed to run pivot on other operations. So basically, we managed to progress a little bit in this table. Next, we'll need to set up the overlay file system. So far I've said we have capsysadmin inside the unprivileged user namespace, but unfortunately, it's not enough for overlay. And there are additional restrictions that blocks us from doing that. It comes from the Linux kernel. Some file system type supports running in a new user namespace, and some don't support that. To be able to know that, you can grep this flag in the Linux source, and you will see some file system supports running in a user namespace, for example, procfs, sysfs, cgroup, tmpfs, etc. And most of them actually don't support that. Initially, it was not supported, and the support is added little by little when it needs some fixes for each file system to be able to do things properly. One difficulty is that since any user without privilege could mount something, that could be potentially dangerous if it is backed by a real block device, for example, because the user could control anything on that block device and try to trigger bugs in the kernel. So that's opened a lot of potentially security issues. But little by little, the features progress, and hopefully one day we will have more support for more file systems. So if I go back to overlay FS, in upstream kernel, this is currently not supported. You can only mount overlay FS on the initial user namespace and not in a new one. There are patches for doing that in Ubuntu. And they did the work for making it work for overlay and fuse for a few years now. But that work until recently was not in upstream kernels. But now in the next kernel, 4.18, which is not released yet, there will be fuse additionally, so we will be able to mount fuse in a new user namespace. And hopefully, overlay FS will come soon after. The patches are there in Ubuntu, but they need a bit of work to merge it upstream. So in this table, we don't really have overlay FS yet, unless you are running on Ubuntu or you use those patches. But hopefully it will come soon. Another potentially difficult thing is the proc file system. So the proc file system has this flag. That means the FS user NS mount. It means it should be possible to mount it in a new user namespace. But actually, in some configuration, it actually doesn't work in Docker. When you have a program running inside Docker that create a new user namespace and a new mount namespace, it could fail and could refuse your command. So what's going on there? To be able to understand, I need to talk about a feature that is used in some software. The feature is when you mount a file system on a directory, it hides the files that were there before. So the mount over hide what was there before, and you see the mounts instead of the files in the previous directory. That's a common pattern that is used for some security features. I will give an example in systemd and in Docker. In systemd, when you start systemd service, you have some configuration option that you can put in your unit file, your systemd unit file. There is basically two options, read-only path and inaccessible path. What it does, I will start with read-only. It does a bind mount of the directory, but remount it read-only. So the service will not be able to modify the files. So you could configure, for example, system services will not be able to access /home, for example, or accesses read-only or not at all. As every mount, that's protected by capsysadmin. So if you use those options, but at the same time give capsysadmin to your systemd service, that service could potentially use that capability to unmount the protection you just put. So that's why in documentation of systemd is suggested if you don't want that, you should not give capsysadmin to your application. Docker use the same ID very similarly. If you start a Docker container, you will see a list of mounts in /proc. And a lot of them are, you see it's read-only here. What does Docker do by default is to remount some subdirectory of /proc as read-only so that your container cannot by default do dangerous things. For example, you have /proc/ccircuittrigger that can be used to reboot your machines. We don't want that by default unless we explicitly want that. So by default, it's mounted read-only. Of course, you can give capsysadmin to your Docker container, and then the Docker container will be able to undo that protections, but that's up to you. And below, some files or directories are bind-mounted to completely hide some files in /proc. For example, /proc/kcore. You can access the full memory of your system here, of the kernel memory. That's dangerous. So by default, it's disabled in Docker. So far I talked about hiding a subtree in systemd on Docker with a bind mount. That could be disabled or removed if the process has capsysadmin. But do you think it's possible to circumvent that protection even if you don't have a capsysadmin? You could create an unprivileged user namespace, and then you have the capabilities inside that user namespace, and then you could try to unmount that. Do you think it will work? Well, it doesn't work. The kernel tries to protect against this kind of things. I will explain on this the kind of protection that happened here. On the left, I have the host mount namespace with the directories on the mounts. In the middle, I have a systemd service, and I use the option protect home equal yes. What it does, it will do a mount on /home to make it read-only, how to hide it. And if that systemd service try on the right to create a new unprivileged user namespace, and a new mount namespace from there, all the mount tree will be duplicated. But the kernel will remember, oh, that's come from a different user namespace so I'm less privileged than the host. So the kernel will put some kind of protections there. What it does, it put the flag mnt lock to say those mounts are locked and they should not be able to remove it. So that's one protection, and there is different protection specific for proc on sysfs. If I come back to what I was trying to do in the first place, I was trying to mount a new proc file system in the Docker container to set up the build container. I was not trying to change, unmount some protection. I was trying to build a new, completely new proc file system. But there is something specific to the proc file system and the sys file system. Some files in there are actually not specific to the mounts, but are singleton on the system. This example, /proc/ccircuittrigger, if you mount the proc file system several times, it's not different file, it's exactly the same interface to the same kernel. The kernel knows that, so it put specific protections on the proc file system. And if you try to mount a brand new proc file system, it will see, oh, actually there is a previous proc file system, and there was some protection there. So I see you are trying to go around that, so it will not allow it. So we have seen two different mechanisms to protect those mounts. Locked mount and that protect systemd service on Docker container, for example, for trying to unmount things inside. And the other one specific for procfs and sysfs. So what can we do? There is different ideas to be able to have our build container. You could try to avoid mounting /proc in the first place. I'm sure there are plenty of Docker files that don't really need that, so maybe we can just not do it and fix any Docker file that needs to have a /proc to do things differently. Another approach was to add an option in Docker and in Kubernetes to say I don't want to mount /proc with all these hidden files, to all these bind mounts, but instead mount a raw /proc with all the capabilities, and that's the approach taken by AMG. That makes it a bit more dangerous because that's giving some privilege, but at least that's better than not working. Another idea is to, there are some pages in the kernel to do /proc in a completely different way. At the moment, the API for /proc is not really great because it mixes two different things. There is the list of processes there, but there is also some configurations kind of files like a C-circuit trigger and others. And there is this idea to give this mount option to say I only want to see the process but not the dangerous files. So hopefully that's something will be come up, and once we have that, the containers could use that, and that would be safer. So that's the summary. I've not talked about everything there, but some of the aspects that in the Linux kernel that make it difficult to have unprivileged container builds. And there is ongoing work in the kernel to be able to improve some aspects, like the overlay file system on mounting /proc. I can take some questions. Before that, I just wanted to say at Kinvolk, we organize with others this conference, All System Go. That will be in Berlin in September about all user space Linux. Any questions? I think that's different things. I would like that to work in standard Kubernetes containers without giving privilege to pods. So I don't exactly know, but I think that if user namespace were used in the first place, that will be great. But although I use user namespace to set up a specific configuration of user namespace. I use it to have all the capabilities there. So I'm not sure the default Kubernetes configuration, if user namespace were used there, will suit that. I forgot your first question, sorry. I think I use overlay to make it easier to track what kind of modifications are done. So the same could be done without overlay. I think AMG has code to use fuse. So all the change you do on the file system will go to the fuse daemon and keep track of that change. But yeah, I think overlay is a nice way to do that. That's not really for security boundary. I think that's just to keep track of change. Yes? Right. The question is about gvisor. I've not read in detail gvisor, but I've seen in the README that it's used two different possible implementations. One is with ptrace. So I think you will need to be able to give that ptrace capability in your containers. And the other implementation they have is with QEMU, I think. So I don't exactly know how it works with QEMU, if you need to have a privilege to give QEMU. But hopefully, we'll see how it improves after. Other questions? OK, so thank you.